All right, good afternoon, everybody. My name is Bob Christenson. I'm the product manager for the controls group. Give you a little bit of information about me. Been employed at Chore-Time for over 25 years. I've been the product manager for the CHORE-TRONICS line since 2009. I graduated from Ohio State University. I'm married with 3 adult children and 1 grandchild, and in my spare time I like to do bike riding and restoring old tractors. Mostly the red ones, but I will work on a green one every once in a while if it's around. I'm going to talk to you a little bit today about environmental control, some things that we're sensing and emerging technologies, and things that we can do to help improve house management. In particular, we're going to talk about controlling moisture levels in a poultry house, and why is that important and what we can do about it. So some of the topics we're going to talk about today is, why is controlling moisture important? Why should we care? Where does the moisture come from? How catalysts can help control that moisture in your house? And some upcoming moisture control features that will be coming in the Catalyst and CHORE-TRONICS 3 controls here in the near future. So why is controlling moisture in a house important? Why should it matter? Well, according to the University of Georgia, excessive moisture in the house will lead to several things. Wet litter, so obviously the more moisture it's in the house, the wetter the litter is going to be. There'll be increased incidences of pododermatitis, so foot pad issues. Increased levels of ammonia in the house. That's something that we've known for quite a while. The higher levels of ammonia that are in the house, the more ammonia that'll be produced in a house. Now, with that increased levels of ammonia, that's going to lead to reduced weight gains on the birds, so it'll take longer to get to market weight. Increased feed conversion, so it'll take more feed to get to that weight. Increased susceptibility to disease will also happen if we have excessive levels of moisture. And then that's just what's happening, that can happen to the birds. On top of that, excessive moisture allows high concentrations of condensation ammonia to end up on your equipment, which can cause corrosion and shorten the lifespan of that equipment. So not only can it be detrimental to the bird's health, it can be detrimental to your equipment health as well. So where does this moisture really come from? Is it just appearing? Where does it come from? It almost comes exclusively from the bird. So the water that the bird is taking in, almost 100% of it, the water that the bird takes in ends up out into the house, whether it be in the air or into the litter. So every ounce or every milliliter that the bird takes in, it's got to get out, and we need to get that out of the house to maintain a lower moisture level in the house. So because of that, it's important that we set ventilation rates that will remove the moisture from the house. That helps keep the relative humidity down. That's most of the way that we've controlled moisture up to now, is measuring the relative humidity. The CHORE-TRONICS controls have had a feature for a long time that as moisture gets too high, relative humidity gets too high, we can increase the minimum ventilation rates. So that's always something that's been there, but we've never had that verifier that, hey, are we really removing enough moisture into the house? By keeping the moisture out, we keep the floors drier. That's obvious. As we remove the moisture from the house, that's going to help keep that litter dry and in good condition. It lowers the ammonia level, better air quality in the house for both the birds and for anybody that has to be inside that house. If the RH is already high, though, we may have to ventilate more than what we are just to remove the moisture that's coming in now. So if you're starting out with wet litter, or you're starting out with very high ammonia rates, you may have to go ahead and ventilate more than what you normally would just to remove the moisture to get those houses dried out. So how much ventilation do we really need to remove moisture, and how do we figure that out? The amount of minimum ventilation needed can be calculated. Here's what you need to know in order to calculate it. The amount of water coming into the house, you can get that from the water meter that's present in almost every poultry house today. You need to know the house temperature. What's the temperature inside the house? The relative humidity inside the house. And by doing that, you can know then how much moisture carrying ability is in the air. So the warmer the air, the more moisture it can hold. You need to know the outside temperature of the income, because that's the air that's coming into the house as you ventilate. And the outside RH, again, to know the moisture carrying capability of the air as it comes into the house. And then you need to know the performance of the fans you're using to do the minimum ventilation. So, whether you have 2 57-inch fans running or 3 48-inch fans running, you need to know how much ventilation you're doing to get that going on the house. Now, if you have that information, there's an app that's available from the University of Georgia that does a great job of helping you calculate how much ventilation that needs to be done. You put in that information that I showed on the previous slide, and how much ventilation, how many fans you're running to do minimum ventilation. It tells you how much you need to do to remove the moisture. It's a good way to get a calculated amount of ventilation needed, although it is a bit of a spot check. So you put in how much water you think the birds are drinking right now, and then that'll set your ventilation rates. The next day you may have to do that again and run that check again. But it is a very nice tool to get you an idea of how much ventilation can be removed. So with that knowledge, what can the Catalyst do to help that? Well, Catalyst does have a built-in calculator that is constantly updating the amount of time that you need to remove the moisture out of the house. So it knows the fan performance, and it'll know if that fan performance changes. So if your static pressure starts running higher in the house, fans aren't moving quite as much air, it can adjust for that. It'll recalculate if temp conditions change or humidity conditions change. So if you're drying that house out, it'll know that it's coming in, or if the outside conditions change, it'll know that. It knows if the static pressure changes in the house. It can make all those adjustments, and then it puts in this line right here how much on and off time you need to ventilate to remove that moisture. And then on top of that, it'll tell you how much airflow that equates to. Now, it can also do, if you live in an area that changes litter out every time, or is in a different climate where moisture removal maybe isn't as important, it can also tell you how much minimum ventilation you need to remove heat out of the house from the birds. In order to do that, you do need to add a bird scale so it knows the weight of the bird, so it knows how much heat is being given off from the birds. But it can do that also if you want to. But in most cases, the moisture removal is going to be the calculation that rules the roost. And then on top of that, if you're looking here, it'll say, look, here's my current min vent time. You can do some comparisons with that. You take a look, hey, you can compare these two numbers and say, if the moisture removal number happens to be higher than what your current min vent time is, you can say, hey, I'm not running my fans long enough to get all the moisture out of the house. And then you can go in then and change your minimum vent level to match what it currently does. That way you always know that, hey, at least I'm getting the moisture out of the house. Now, based on other things like our relative humidity levels or the temperature influence feature that we have in the controls, where as it warms up just a little bit, it adds a little bit more ventilation. Maybe this number is already larger than this number. If that's the case, that's okay. We're already running the minimum ventilation enough to get all the moisture out of the house. So we're okay there. So what does the Catalyst or the CHORE-TRONICS 3 need in order to accomplish this? Well, it needs to know house temperature. Well, that's going to be there anyway, because you need house temperature to know when to turn fans on and off and everything too. So that's pretty much a given. That's going to be in most places. You're going to need to know the house RH. So again, that's not a standard sensor that comes with the control, but it is available from us. You put that in the house, you'll be able to get a relative humidity reading in there, and then you've got that information. And then it can be used for other things like RH influence on minimum ventilation. You can use it if you're using evaporative cooling and the humidity gets too high in the house to maybe back off how much evaporative cooling's going on. There's other uses for that RH sensor besides this calculation, but this calculation is an important one. Outside temperature. That's something, again, that we've had available for controls since the CHORE-TRONICS 1 for many years. That's something that's been used a lot to do calculations or take action on the control. Now we've got something that we're doing with it. Outside RH, that's a fairly new sensor that we've added on the CHORE-TRONICS 3 that's available. And here you can see a way that we have suggested to hang a sensor if you don't have an outdoor one that's an RH sensor and a temperature sensor that's designed for outdoors. You can put it underneath the cover, put some holes in it for ventilation, hang it underneath the eave. You got to keep that temperature sensor out of the direct sunlight, and you can get those readings, and they're pretty stable on that. And then finally, a water meter. Let that control know how much water is coming into the house. That's pretty much standard on most poultry houses these days because we want to know what the birds are consuming, when they're consuming it, all kinds of information. But it is something that you do need. And then finally, the Chore-Time fan model. Inside the control, when you're setting it up and you're assigning relays to it, we have a whole long list of our most popular fans, the ones that we usually sell the most of, that you choose. And when we choose that loads the performance data that we get from Best Labs. Every fan that we sell, we take to Best Labs over at the University of Illinois to test for their performance. We load that performance information into the control. And by doing that, we know what that fan's performance is at different static pressures. And in the case, if we're happen to use one of our new direct drive variable speed fan or one of the other variable speed fans, we know what that speed is at different speeds and different static pressures. So by doing that, we can get a fairly accurate calculation as to how much ventilation we need in order to get the moisture out of the house. So choosing a fan model, as I said, we've got many of the Chore-Time models listed. I already mentioned it uses the Best Lab data for performance information, so it should match up with what you see there. And then it changes the so if anything changes in the house to the fan, static pressure that it's seeing, the speed of the fan, anything else like that, it adjusts its performance data, and it does well. And then, as I said, that allows for a more accurate performance than just doing a spot check. Again, that University of Georgia app does a great job of doing a spot check of what you need, but this will give you a constant reading as to what you need, and you can check it throughout the day. If you happen to be using C Central or our Synergy product for data collection, you can compare that throughout the day to see how you're doing throughout the day. So there's all kinds of things you can do with that stuff. So what are we going to do with this next? It's like, yeah, that's great and everything, but we got to manually go and change it and check maybe several times throughout the day and do different stuff with it. Well, it's coming up later this year. The Catalyst is going to be able to bump up the min-vent on time to match what is needed to remove the water. So before every min-vent cycle, it's going to check, hey, what am I running at? And compare that to what it's showing, and if it needs to, bump it up a little bit. If it's already up there, it'll leave it alone because there could be other reasons why it needs to run more. But at least it's going to bring it up there a little bit. So, as I mentioned, it will take the temperature and humidity influence into account. So if they're already adding enough time to get us at or above that moisture removal calculation, it takes no action at all. It just says, yep, that's what I'm going to run because I know I'm at least removing the moisture out of the house. And really, with all those things combined, you may not see much need for the water removal calculation to have to kick in because you're already controlling the relative humidity in the house and doing a good job with that. Should be available mid-year this year, 2024, in both the Catalyst and the Chore-TRONICS 3. So we'll just see how the testing goes with the influence part. We've had the calculator out now for about 2 years, and we've got several people that are using it and making use of it, and they have seen great results. Drier floors in the house. In some cases, they're getting on top of this early so that they're not having to run more heat later in the flock to try and dry the houses out, because they've maintained that relative humidity level from the start. So if you have any questions, you can scan the QR code that should take us to our website. You can come and see either myself or one of the other folks here on the floor over at the controls area. We'd be happy to talk about this with you more and see what we can do for you with it. Thank you very much for your time today.